What is up, folks? This is Mr. Walker coming at you live from the internet. We are talking about the Pythagorean theorem today. Pythagorean theorem. All right, it's been a minute since you've seen a triangle, so hopefully we can explain what this is in terms of this triangle. All right, first off, let's talk about some things. All right, imagine we had three different squares made up. We had the first square here with all nine of these. This is made up of 3 times 3. So the area of this whole thing is 9. Now our next biggest one has 4 squareds by 4 squareds. And if we're looking at the area of this, it would be 16. And then the biggest one right here is 5 by 5. And the area of that is 25. Now imagine if all three of these were laid up on the sides of one shape. Since there's three, you know what type of shape we're talking about. We're talking about a triangle here. Things to note. This triangle here has sides according to what these three are. This side here, A, is 3 blocks long. This side here, B, is 4 blocks long. And this side, C, is 5 blocks long. So if we were going through and dealing with this and we ever had to find out whatever one of these numbers is compared to the other, we would use this brief little formula. So first thing that we got is what everything equals. Now everything on this triangle equals the biggest side squared is equal to the smallest squared plus the one that's in the middle squared. Now as we run through this, 5 squared, is 25, 3 squared is 9, 4 squared is 16. So let's simplify that. Now if you were able to go through and see this, you obviously know 9 plus 16 is in fact 25, which means that this formula here helps us to find any of these possible sides as we go through and deal with it. That formula is c squared equals a squared plus b squared. Or you might know it as a squared plus b squared equals c squared. So this is the Pythagorean theorem. So let's get into some definitions so that you're able to go through and use it in action. All right. The Pythagorean theorem is dealt with this type of triangle. If you remember, when you see this is a right angle, which makes this triangle a right triangle. Let's talk about the parts of it. First part that we got is called the hypotenuse. The hypotenuse is the longest side of a right triangle. This is the side that's opposite the right angle and is usually labeled as C. So up top, we got our hypotenuse C. Now, this is the same C that we had from the formula, so don't forget about this. Now, we're talking about the legs, the other two part. These are the short sides of a right triangle that form the right angle. These are labeled A and B. So by short sides, I mean shorter, obviously, than this side up here. So we got two sides. We got the side on the left, that's one leg. We call that A. We got the other leg, and that's called B. Now these two, A and B, these are the A and B from our formula. So let's talk about how the formula works. In a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the legs. Okay? So whatever the leg is squared plus the other leg squared equals the hypotenuse squared, aka c squared equals a squared plus b squared. All right. Now, as we go through and deal with right triangles, you might have something that's called a Pythagorean triple. Think about this as kind of an auto win for this type of formula. So, a Pythagorean triple is a specific set of positive integers that satisfy the Pythagorean theorem. Here's a couple that you can get used to. So if you see it, you automatically know it is what it is. It's going to work. We got 3, 4, and 5. You got 6, 8, and 10. You also got 5, 12, and 13. Now for this is stuff that's been tested out, worked out in the past. I don't want you to think that there's a particular trick that we go through and deal with it. Don't think of it like it's a trick, okay? It's going to be a lot if you deal with it like that, okay? All right. Let's talk about some practice, folks. Let me see what we got here. I believe we got. Yep. Let's get some practice in. Let me make sure that we don't got anything else crazy popping off at us. Um, Sorry about that. Got to pull up our notes. Do 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 do. Okay. Pythagorean theorem. All right, cool. Let's go through and let's deal with it. Let's talk about the we do it on the right side. All right. All right, we do it on the right side, and we also got this one for you. This is underneath the definition for the Pythagorean triple. All right, first step. We're looking at this right triangle here. The missing side that we're looking for is this one right here. This is our hypotenuse. So if you want to write out what the things are, it's always good to, get that little bit in there. We got two legs, A and B. They give us this side up here, C. So let's math it out. We got C squared equals A squared plus B squared. C squared, we don't know what it is, so we're leaving it as C. The other two we can plug in. So we got 13 squared. We got 2 square root of 14 squared. Now, it's important for you to use your calculator, use the math that's given to us, write the stuff out. Don't just do it willy-nilly. So 13 squared gives you 649. 2 square root of 14 squared gives you 56. This is because you have 2 squared that's in front of it, that's 4. Inside of here, this square root of 14 cancels out with the radical, giving you just 14 times 4, which will make 56. Now, we add these two together to give us 255, and we need to find out what C is. This is just what C squared is. So if we're going to go backwards, we're going to have to take our good old friend, the square root, which gets us down to 15. Now, anytime you're going from something squared down to whatever that something is, you got to take the square root, folks. All right, I'm going to give you two more, and then I'm going to give you a bit of practice for you to do on the other parts. You're going to do that on your own. Then you're going to come back and check on our digital notes. All right, next one we got the formula. We're trying to find this time one of the legs because that's what's missing. So let's fill in our information. We got 18 squared equals 15 squared plus x squared. So let's go through and square some stuff up. 18 squared gives you 324. 15 squared, 225 equals x squared. Now with this, we got to do some subtraction first. So we're going to subtract 225 from both sides, giving us 99 equals x squared. Now, I need to go through and take the square root of both sides. Things to know, 99 is not a perfect squared, which means that we will have something in radical form. So we split up the two things, and these are going to give us 9 and 11. And that'll be our final thing. And we take that square root. So this is our answer. Okay. Actually, take this with this is a typo. My fault. I believe this should actually be 3 because you would split up the 2 and then that would make a 3 when you take the square root of it. My bad. All right, last one. We got both of our legs. We're missing our hypotenuse, so it's going to be similar to the first one that we did. So c squared plus a squared. Sorry, c squared equals a squared plus b squared. We don't know what c squared is, so we're leaving that. We got 10 squared plus 10 squared. That gives us 100 plus 100, which is 200. Now, the square root of 200 is not a perfect square, so this will be in radical form, okay? You got to split up the stuff that you need to. I believe this could work with, um, There's actually a couple different ones that you could do. Now, with this, I know you can split this up as 100 and 2 because that's the biggest. Square root of 100 will give us this 10 here. Square root of 2, that'll be inside of our radical. And that's our answers right there. Now, you got a couple different ones here showing up. We got some work asking to check if things are Pythagorean triples. That just means that you got to run it through the Pythagorean theorem. I'm going to let you work on that on your own. We also got a little bit more math popping up at you. Let me pull up our notes so we can see it. You got one right here, one little word problem, two word problems. For these two, you're going to need to draw a picture to most likely help you out. So use the information that we got, and I'm going to see you later.